Welcome back, everybody. Happy Monday. This week, today we have some review, tomorrow some more review, and then Wednesday we will do our test. By Thursday, I need you guys to go over to the bare necessities and get our new. By Thursday? Thursday. And it's yellow. And just a heads up, I don't know why they didn't do it, but it doesn't have the spiral bounding. It has 3-hole punch, so you should put it in a 3-hole binder, I guess. Sorry about that. Huh? Well, you got till Thursday to get one, right? Must be Canadian or something. All right, guys, girls, make sure you have your iPods or other electronic devices out of your ears, off. Phones off position. They can be on your desk, but you're not using them. They're off, please. And I wanted to give you guys the opportunity to ask questions you might have come across from old worksheets that we could go over. And if we don't have any of that, then I do have stuff on the board that we will also go over. So, and everything that we will be doing today and tomorrow will be completely related to the test, so please feel free to ask.
We go over like graphing problems with true, false, true.
Cool. Let's do it. So, do you want to make something up off the cuff, or?
Yeah. Sure.
Okay. Let's talk about. So, we were asked, can we go over graphing where we shade the region? So, first thing I want to focus on is if I just had two different values that were graphed, and I don't know what these equations are off the top of my head, but I have, say, this, and then let's say I have this one.
I like that.
Killing me.
Killing me small.
All right. So a few things to think about is we have this region here, this one here, this one here, and this one here. One of those regions will be a true-true, one will be a false-false, one will be a true-false, and one will be a false-true. Meaning when I pick a test point, and I plug it back into both of the equations, the result of the question is you have a true scenario and a true. So it could be like 3 is greater than -1 and 5 is less than 10. That would give you true and true. Or if you get something that would give you a true on the first one and a false on the second one, that wouldn't be the region you shade. The nice thing is if you happen to find the false-false, so let's say right here gives us the false-false, right across the way would have to be the true-true. So if you did have to find the false-false immediately, just go diagonally across from it, and that would be where your true-true is every time. Okay. If you found the true-false, then so if this was true-false here, then this region down here would actually be false-true, meaning you plug it into the same order of your equations that were given. So that's the first part you have to understand. You have to realize that you do have a solid line or a dotted line. If it's a dotted line, it's either going to be this or this. If it's a solid line, you would have this or this as your sign. So the solid line, you have the line that's underneath it in order to generate. So let's come up with a problem that would work, that we'd go through. Let's say we had 2x minus 3y is less than 12. Okay, let me just make sure I can make this right. Okay. So let's try both of those. These are two different equations. One of the equations I'll be able to use the cover method, and the other equation I'll be able to use where it crosses the y-intercept and use the slope. Okay? Good so far? Happy day? Oh. Get you a couple tissues. Here you go, Bo. All right. All right, pulling the cards out. Let's see what we do. Megan, the very top equation, I'm going to circle or box in, be in red, so we'll graph it in red. Is this going to be a solid or a dotted line? Dotted, okay. So this indicates that it'll be dotted. Okay, if I were to use the cover method, Megan, and I were to cover this, I get 2x equals 12. So what would my x component be? 6. So in the x direction, I go 1, 2, 3, 4, 5, and 6. Okay? And then, TJ, if I cover up right here, what's my y component? Negative 4. And TJ, we said this was going to be solid or dotted, I forget. Dotted, and the reason we know it's dotted is because of what?
Because it's not included.
Right. We don't have the equal sign underneath it. Okay? Preston, welcome back. Picking on you. Okay, this second equation we're going to look at, we're going to do in green. Is this going to be a solid or dotted line? And how would you know? Be a solid line? So how do we know it's going to be solid? What stands out? Make it solid. Yeah, arrow with the line. So you have the equal sign as part of it. Very good. This particular equation can be graphed where we have the y-intercept, and then we use the slope to find the second one. So Preston, what's my y-intercept up here? That's the slope.
Oh, my bad.
1. There you go. Okay. And then Bo, what's my slope? Right, so from this point, I'm going to go down 3, 1, and 2, and 3, and I'm going to go over 5. 1, 2, 3, 4, and 5. And, Bo, did we say this one was going to be solid or dotted? Solid, and the reason it's solid is because we have the equal sign as part of it. Still with me? Okay. George, what would be a nice test point to start out with? 0, 0, okay. So this right here would be a pretty good test point. The reason I think it's a very good test point, George, is what reason? What do the lines not do to 0, 0? They don't. Yeah, they don't cross it. So neither of our lines will go through it. So this 0, 0 is definitely down in this region here. And if this gives me a true, true, I'm going to shade this region here. If this gives me a false, false, I'll shade this region over here. If he gives me a true, false, I should pick something over here or down here to find the true, true, okay? All right, so I'm going to take 0, 0 and plug it in. So if I plug 0, 0 in here, I get 2 times 0 minus 3 times 0 is less than 12. Mackenzie, is 0 less than 12? Yeah, so that's true. Okay, so it gave us one true so far. Hopefully if it gives us a second true, we will shade that region. If it doesn't, we need to go seek it out. So I'm going to take that 0, 0 and plug it into this one as well. And I'm going to get 0 is greater than or equal to negative 3/5 times 0 plus 1. Mackenzie again, negative 3/5 times 0 is how much? 0. So 0 is greater than or equal to 1. Zero is greater than 1? Less than? So that's false, right? So this gives me a false statement. So if I have true, false over here, Karen, what would this region be over here then? If I had true, false in this region over here, what would this region be over here? Good. So I need to pick another point that would be, that I could test. And so I don't want to pick anything in this region because everything over here would give me false, true. If I pick anything over here, this gives me false, or true, false over here, false, true over here. So it's always good to try and pick another test point that includes one of its components being 0. Okay? Ray, I want to pick another point, but I'd like one of the points to be 0. And I'd like to either pick it somewhere up here or somewhere down here. Anywhere look particularly okay for you? 3, 0? I like that. Okay? Now some of you might be looking going, why didn't you pick like some point like 0, 10? You could have. But sometimes people's minds are going to work a little differently, and that's okay. That's what makes us all beautiful. Okay? So 3, 0 definitely works. This green line is underneath it. This red line is below it as well. So 3, 0 works well. This is x, and that's a y value. And if I plug those back in here, let's see, I'm going to get 2 times x minus 3 times y, which is 0, is less than 12. Is 6 minus 0, is 6 less than 12? True. Okay, so I'm pretty sure this is going to be true, but just let's make sure so we don't make an error. Just a good behavior. Let's plug it in here. So I have a y component being 0. 0 is greater than negative 3/5 times 3 plus 1. Excuse me. 0 is greater than or equal to negative 9/5 plus 1. Negative 9/5 is pretty close to negative 2. So is 0 greater than a negative answer? Yeah, that's true as well. So here's the true. So that gives me the true. So it's this region here that we're going to graph and we're going to shade. This problem would be worth, let's see, if you got the green graph right, there's 1 point. If you got green and solid, there's another point. If you got the red line correct, that's a 3rd point. If you got the red dotted right, that's a 4th point. If you shaded the correct region, that's 5th point. So this is a 5-point problem. Okay? But is it possible to get partial credit on a problem? Yeah, if this is a 5-point problem and you shaded right here, how many points do you think you would get?
4 out of 5.
Yeah, 4 out of 5. So that's not a horrible thing. So sometimes, and some of you are guilty of this, if you sit there and put a big question mark, that makes it really easy to grade. That's just 5 off. There wasn't a thought process that went into it. Yeah, you did. No, you didn't. Put a question mark on something that we reviewed isn't an application. Okay, that's like on the, when you were in 2nd grade, it's like, why did Billy go to the store? Because. Okay. And your teacher's like, this isn't a full thought. Well, yeah, it is. He went because. You're talking about a predicate nominative. It has nothing to do with a full thought. So, all right. All right, guys, girls, let's move on. Ben, is that a good one to do?
Yeah.
You like that? What's another type of problem we'd like to take a look at? Any ideas? If we don't have any ideas, what we'll do is we'll go through those problems. Word problem?
No. Yeah, we need to.
Okay. I have 2 word problems I've written up on the board. Can we stick with them?
Yeah.
Is that good?
Can we do one that isn't
Yeah. You want to do a rectangle one?
sure.
Okay. So let's try a rectangle one. Rectangle has a perimeter of 40 centimeters. If the length is 4 more than twice the width. Okay, Sophia. Rectangle has perimeter 40 centimeters. If the length is 4 more than twice the width, what are the length and width? Sophia, what would be a good place to start on this problem, do you feel? Okay. So, getting some information down. We have this. That's a go-to perimeter equation, right? Do we need the area equation on this problem? No, it's not asked for the area, so we can list it. It's not going to be wrong. You list things and say, okay, these are the items I'm going to utilize for the problem. So if you put the area equation, you're not wasting time. It's just your thought process is going in a way that you need to go. All right, so we do know 40 equals 2L plus 2W. So Sophia's still picking on you. at this point, I know I have L and W that are still unknown. So right now, I can't really solve unless I go a little bit further. Do you agree? Okay. Okay, Casey. What do we know about the length or the width? What's told to us up here? Yeah, so if we know this, four more than twice the width. So the length is equal to 4. How do you do 4 more? 4 plus. How do you do twice the width? 2W. So now that's our relationship of the length to the width. Casey, what do you feel I should do with this and with this? Substitute. What am I substituting in for? L. Good. So I know that L is equivalent to this relationship. So I'm going to go to this problem. I'm going to go 40 is equal to 2. There was an L there. If there was an L there, what's now going to go there? 4 plus 2W. Ben, help me out. How do I start resolving this problem now?
You distribute 2 to 4 and 2W.
Perfect. So that gives me 8 plus 4W plus 2W. Is that okay so far? A few things I can do. That gives me 6W. Subtract 8 as well. That gives me 32 is equal to 6W. So divide each side by 6. So I find that my width is 32 over 6. That'll reduce to 16 over 3, which would be 5 1/3 if you converted that. So if you know that to be the case, if you plug this back in here, if I double that, this is going to give me 10 2/3 plus 4. So that's going to be 14 2/3 will be my length. So my length is that, my width is that. And I guess to make it appropriate, centimeters. Sweet. If you were working one of these problems and you came out to a negative length, what can you conclude? Okay, you might have done it wrong, but it also might be a no solution. Okay? Is it possible I make an error on the test? You know, sometimes when you work out a math problem and it's coming out as something obscure that it shouldn't happen, like you have a negative length or you have negative money, it might be no solution. Okay? Now, I'll tell you this, don't go through the entire test with no solution for every problem going to do it. I know I'm going to get at least one right. Okay? I've had a couple kids back in my past. It's like, hey, I want to just let you know that of the 20 problems on here, there's 2 of them that are no solution. And a kid will go through and put no solution for every problem going through. I got 2 of them right. Good job there, Rockstar. You got 18 of them wrong, though. Yeah, but 2 are right. Yeah, good.
Better than nothing.
I understand. I'm with you. Is there another type of problem that we want to see? Another word problem? Do we want to see another? What's that? Well, what kind of word problem would you like? Money? Money? All right. All right, let's use the word problems up here. I have 2 different word problems. You have 12 coins, and they have to be dimes and quarters. And you have a total of $2.35. Okay? Gabe, if I have 12 coins total, consisting of dimes and quarters, what would one of the equations be, do you think? I like it. Q plus D equals 12. You reach in your pocket, you're like, take a look. I have quarters and dimes only, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 coins in all. You didn't do the summation of everything. You're just trying to get there. Gabe, a quarter is worth how much? 25 cents. So I'm going to go 0.25Q. And a dime is worth how much? 10 cents. So I'll do 0.10D. And that's equal to 2.35. Gabe, how would I get this not to have any decimals? Oh, I like how your mind's working. I really do like that. No, I do. I do. You're right. You're right. I like it. Okay? So I was trying to get rid of just the decimal amount, but you went right to going, well, I know that if I multiply the whole bottom by -4 and I add up, this will become a -1 because -4 times 0.25 is -1.00, which is -1.
Yeah.
So you could get rid of your decimals. You could try and get rid of them just by taking it. So let's see if that'll work. I like what you're thinking. I was trying to get you guys to realize let's multiply by 100 so we don't have any decimal amounts, but I think Gabe saw it. I like it. So let's do this here to here to here. Let's see how it works out. -4 times 0.25, as I said, is -1Q. Okay? And then -4 times 0.10 is -0.4D. Can I make that work? And then -4 times -2.35. Does somebody have a calculator out that can help me with it? I can't do this in my head. I'm sorry. If it was just doubled, it'd be 470. 540? 540? Someone double check my work. I think it might be this. So -4 times 235, I think. It's 940?
Yeah, you're right.
940 or 540?
Oh, it's
940? Okay, jeez, thank you. All right. So, I'm going to bring this one down below. So I have Q plus D equals 12. So if I add these together, -1Q is the same thing as -Q. So this is going to cancel this. -4D plus 1D is 0.6D. Can I do that?
Oh.
Right? Help me out. What is -940 added to 12?
21. Wait, no.
940 plus 12. 2.6, thank you. And then, how am I going to get this 0.6 gone? Divide by 0.6. So D is equal to, what's 2.6 divided by 0.6?
4.3.
4. Uh-oh. Uh-oh. What happened here? Were we wrong? Andrew, can I have 4.3333 times? What do you think? Best guess. You think it would work? Oh, no. This is a nonsense type of answer. Does everyone get that? So this problem, though it looks like it could be work, going, okay, I got 12 coins total, having to be dimes and quarters, making $2.35. Being I was able to solve this problem, and I came out to 4.3333 repeating it forever dimes, you're not going to come up with 4.33 repeating dimes. You're not even going to come up with 4.3 dimes. Okay? So there is not going to be a solution to this problem. Okay? And that's important to know. That's important to know that sometimes you might work out a problem that there might not be a solution that would work.
What if you multiply the top numbers like 500?
Doesn't matter.
Okay.
It's still going to come out the same. We're still, I mean, granted, if we did all of our math correctly, which I believe we did, I don't think we can get a solution. Are there problems in life that there isn't a solution to? Yeah, sometimes people are like, oh, it's a compromise. Yeah, that means you gave up something. Right? Huh. Can I try my other word problem? I don't know if that one's going to work either. I just made it up off the cuff. Can I try it?
Yeah.
Clear in the ink. You have nickels and quarters. That total $4.15. Total coins? Is 30. Okay, you reach in your pocket. You happen to have 30 coins in your pocket. Or you have 30 coins in some place in your backpack or something. I don't know. You pull them out going, oh, sweet, look, they're all quarters and nickels. Hopefully there's more quarters and nickels because that means you got more money. Okay? Ashley, what would one of my equations be, do you think? N plus Q equals 30. So you reach in your pocket, you realize you have nickels and quarters, and then you count how many coins total you have. You're not looking for a value of money. You're looking, oh, I have 30 coins. Cool. Okay, Ashley, do you know what the other equation might be? What is it?
Let's say 2.
Is it 0.5? Is it 0.5? 0.05. Good. Okay. 0.5 is half a dollar. Okay. Plus, what's the quarter worth? 25Q. I like it. $4.15. Okay. I like it. Angelo, I think I want to get rid of my decimals on this one. What should I do to everything? We did do it on the last one, which was okay, but I want to try it on this one. What's going to move the decimal 2 places to the right? Say 10 will move it 1. 1,000 will move it 3 times. So what are you going to change to? Yeah, buddy. 100. I multiply everything by 100. Multiply by 100 will move the decimal 2 places to the right on each of our portions. So I have 5n plus 25q equals 415. And then I'm going to bring my other equation down. N plus q is equal to 30. Okay. Angelo, would you like to get rid of nickels or quarters first? Your choice. So, and I could multiply this whole thing by negative 5 or negative 25. Negative 5, I like it. Multiply everything here by negative 5, distribute here, and here, and here. So the top equation is this. Let's see if I made one that'll work. 5n minus 5q equals negative 5 times 30, negative 150. Is that right? All right, n's are gone. I get 20q equals, oh, shnikes. What's 415 minus 150? Someone calculator. How much? Okay. Someone's calculator. 415. 265? Oh, boy. Guys, girls, you know what I did again? What's 26 divided by 20? 13.25. I have 13.25 quarters. Yeah, your name.
Nay.
It's not going to work that way. Now, you might get the kid that says, dude, but what if you cut it?
Yeah, what if you cut it?
What if you cut it? Cut it in a quarters. Good. There you go there. Let Bill McGillicuddy. You're not going to cut a coin and say, here's a portion of a coin. Accept it. Cut the quarter in half. Here you go, mister. It's worth 12.5 cents. You gotta go. You guys go get them sodies. All right. Let's try some of these. Let's have you guys work some of these. Clearing. 3x plus 2y is equal to 6. X minus y equals 7. Give it a shot. See if you can figure it out. Yo. What's that? Give it a shot. Try it. Yeah, you have a sheet of paper out so you can give it a work. As you're working it, I will kind of parallel y'all so you can glance up from time to time. But if you do have a sheet of paper, get it out.
Wait, is this for the graph?
If you want to graph it, you could graph it. It would graph, but it might not be the best to graph. But if you want it, if that's the way you see it, go for it. You don't have to graph it. You can do it any way you want except for copy off your neighbor.
That's what I was doing.
And I'm going to start it kind of slowly.
Oh, you want us to solve these equations?
I can get it.
So I gave you the first step. Can you figure out some more?
No.
Yes, you can. Get there? Yeah. Look at that same equation. So we got a y value for this one? What'd you get? -3? Anyone else get -3?
Dude, we're talking trees again?
Ah. You agree with that? Do that? Look at that.
Yeah, that's what I
See it?
Yeah, that's still got -3, so either way, alone.
Giddy up, I like it. All right, can we try another one?
Yes.
No, we're done reviewing. I'm just going to complain that I did bad on the test.
All right. Okay, clear?
Yes, please.
Are you still working it, Ray? Are you still working it? Oh, okay, good. Clearing it. Clearing. Let's see. Got a problem is this one. It's a math problem. Good.
One that I don't want to do.
One I don't want to do. Try it. Well, you could try it that way, but I think because it's an inequality, we need to go a little different. Hey, what kind of problem is this other than inequality? What kind of way should we solve it? Graphing. I like it.
Oh, snap.
This is a graphing problem. So for those of you struggling a little bit with graphing, Up 3, right 1. So, I hear some people saying, is that no solution? They are parallel. Here's a question though. Uh-oh. Little curveball, Latches. Little curveball. Am I looking for an ordered pair on this problem?
Yeah.
Am I looking for an ordered pair for the solution on this problem?
Yes.
What kind of problem is it?
Graphic.
It is graphing. What else do we know about this problem? What kind of problem is it? Is it equal and equal? It's an inequality. An inequality means we have a region to shade. So these lines are indeed parallel. And if there was y equals and y equals, this would have no solution for an answer. But it's an inequality. So an inequality of parallel lines, how many regions does it cut our grid into? Here's a region. There's a region up here. There's a region down here. Is there another region? Sure there is. There's a region in between.
Yeah, I see.
Right? So we have this region in between here. We have this region out here. We have this region here. What does a good test point look like? 0, 0. Does everyone agree 0, 0 might be in between these two lines? Right? And if that inside there gives me true, true, we're in good shape. All right, so plugging that in, I get 0 is greater than or equal to 3 times 0 plus 2. So 0 is greater than or equal to 2. That's false. All right. Let's try the other one. 0 is less than 3 times 0 minus 7. 0 is less than negative 7. That's false as well? Say what? So if this region here gives me false and false, that means that I shade out here and I shade up here. Oh boy. Look at that. I had no idea that was coming. So if I give you two inequalities, we need to look at graphing. If the inequalities themselves are parallel, we still could have a solution to the problem, meaning a shaded region. If they are two equal signs, and I have them graphed and they're parallel, I don't have a solution. Hey, how many solutions did I have if it's the exact same line on top of itself? Infinite. So, if I had... So if I had this for a scenario, y equals and y equals, and I had, if I graphed it, if my graphing resulted in parallel, if my graphing resulted in an intersection, if my graphing intersected in
Children.
okay, how many solutions, George?
2.
Parallel.
None.
George, how many solutions here?
42.
George, how many solutions here? Infinite. Okay? So, what does zero solutions look like if we are solving it the other way rather than graphing? What does zero solutions look like if I go and I solve it? What happens? The x and y are gone. Do I get 7 equals 7, or do I get like 18 equals 6?
The second one.
So this would be like saying 18 is equal to 6. This is not going to work. No. Okay? If I had one solution, that means I get a single x value and a single y value when I solve it. I go and break down my problem. I use substitution. I use elimination. I use graphing. But I get an x and a y value. If I have infinite solutions, infinite will be similar to this, but what do you know about it?
Equal to each other.
Yeah, so it might be 7 equals 7. So that's totally true. So if you work it out and you get a true statement, you have infinite solutions. If you work it out and you get something ridiculous, you have a false statement, which means there's no solution. All right, let's work a little bit more. What kind of problem is this?
Math.
Inequality.
Inequality. So I'm going to have to do what to it, Mac? Graph it. I like it. What does that line look like? Straight. Good. Diagonal. What is the y-intercept of that line? 0. Like it. What's the slope of this line?
X.
X. What's the number in front of X?
1.
So up 1, right 1. Agree? Solid or dotted line?
Dotted.
Dotted. Still with me? All right. What's the y-intercept of this line?
Oh,
Negative 1. What's my slope? So I'm going to go up 3. So 1, 2, 3 over 1.
Yeah.
Solid or dotted? Dotted. Okay. Eyes up here, everybody. This will be our last problem. Celine, can I use 0, 0 as a test point? Why not? Yeah, my red line's going right through 0, 0. 0, 0 can't be used as a test point. 0, 0 is not going to work here. Celine, I want to pick something out here, or up here, or down here, or over here. Give me something that would be over here that you definitely know would be over here. 5, 0? I like it. Okay? And again, we're still looking for the true, true. Just because we can't use 0, 0 doesn't mean the problem's broken. So let's take 5, 0 and plug it in. So if I take 5, 0 and plug it in, I get 0 is greater than 5. It's false. So I get false over here. Okay? Let's take the other one. I get 5 is less than 3 times 0 minus 1. 5 is less than negative 1. False. Oh, cool. I found the false false. If I found the false false over here, that gave me false false. Where's the true true? Diagonally across. So over here, this is my shaded region. This would give me true true over here. Okay? Yeah, just keep shading. Kid busts out with a Sharpie, the big fat one. Oh yeah! You know, it's like, bleeds all the way through to the carpet. You're like, dude. Yo! Yeah, let's have you take a look at these problems. Problems to work on. Y equals 3x minus 2. Y equals 7x plus 1. That's one problem. 3x minus 6y is less than or equal to 18. Y is greater than 2/3 x plus 1. That's another problem. 2y equals negative 6x plus 16. Y equals negative 3x plus 8. 3x minus 4y equals 11. Negative 2x plus 4y equals negative 6. There's another problem. 2y, 3x minus 2y equals 10. 2x plus 3y equals negative 2. And then last problem. So 6 problems. Those are all going to be similar to review. Take a picture of it if you need to.
Is it going to be on the video?
Yep, it's on the very tail end of the video at 44 minutes, 44 seconds.